a minute. All right, so yesterday we were talking about the concept of a least common multiple. I need somebody to help me out. What does least common multiple actually mean? Let's go Grant first.
For least, it's smallest.
Okay, so who else can help me out with another word? Sydney?
Common is the same.
Good. And finally, let's just keep going down the road, Jay.
And multiple is multiply.
Good. So what does, we kind of broke down what the words meant. What does this mean? Somebody else, like in your own words, tell me, if I'm telling you to find your least common multiple, what does that mean? Grant? Or let's go, Corinne. I saw your hand at the last minute.
It means that there's two of the same number, but it's the lowest number.
Okay, can you make that a little bit more clear?
It is where you use your timetables and you come up with rows, and then you see the two numbers that are matching, and there might be more, but then you see which one's the least.
Right. Very good. Now, what if I just have just common multiples? Does that change anything?
No.
Just change something.
I mean, yeah.
What does it change?
It's not the least. It's like, it's not the smallest amount.
Okay, and so how many least common multiples? Everybody show me in your fingers, how many least common multiples will you ever have? No, just not common multiples, least common multiple. How many least common multiples? You always have one. And what happens if you don't find a number that's in common after you do 5? What do you have to do? Beth?
You add up, you keep on counting like 12 or 5
right.
until it's a least common number.
Right, because no matter what, they're all going to be in common. So let's go. Beth, mute yourself, please. And everybody, I need 2 numbers so we can practice this. All right, I see a 5, and I see a 7. That works for me. 5 and 7. Go ahead and do that on your paper. And Rebecca, what you're going to do is you're going to count. You're going to go 5 times 1, 5 times 2, 5 times 3, until you, and then same thing with 7, until you find a match. Okay?
Okay.
And then go to ready position when you're finished. Sydney, do you have a question?
Yes, I do. How many?
You do 5 first, and then if they don't have anything in common, then you do 5 more.
Okay, sorry.
No problem. Rebecca, do you have a question?
Yeah, I don't understand the concept.
Okay, why don't you hang out for this problem? This is what we did yesterday. So we'll have everyone explain this one, and then on the next one it should make a little bit more sense.
Okay.
Thank you, Jay, and I think that's Karen. And Grant. All right, as we're finishing up, let's walk through this together just as a nice review. So who wants to start me off with my 5s? Let's see. Let's go. I see. Let's go, Grant. We'll just go down the row again, I guess. So, Grant, you can start me off.
5, 10, 15, 20, 25.
All right, who's taking over for my 7s? Let's go Jay next. We'll go every other.
7, 14, 21, 28, 35.
Okay. What do we do at this point? We have 5 on each. What's our next step? Corinne, what's our next step?
You see if you have any matching numbers, and if you don't, you go up 5 more.
Right. And do we have a matching number? Give me thumbs up or thumbs down. Right. We do not have anything matching. Rebecca, do you understand what we're doing so far? Is this getting you caught up? Rebecca, you got to take this up. Okay, so we're just listing out all of our products, like our times tables, basically.
Okay.
And then we're looking for matches, and we don't have a match right now. So Corinne told us we need to do the next 5 of each one. So we're looking for, let's go, Beth. Can you help me with my 7s?
42, 49, 56, 63, 70.
Okay, and so we do 5 more. That gives us 10. And now either Dylan or Sydney, I need help with my 5s.
Um, 30, 35, 40, and 45.
No, what'd you say? I didn't hear you at the end.
What?
I didn't. Did you say anything after 45?
Yeah, 50.
50.
Yeah.
Okay. Now we're looking for matches. What do we have in matching?
Can't see. Let's see.
We should see 1 match. Grant, or let's go Rebecca. Rebecca, what do you see that they have in common?
They both have a 40 in them. I mean a 35.
I was going to say 35.
Somewhere, some point.
Right. Do they have anything else in common?
No.
No. I will tell you, though, that they will eventually have a 70 in common. How do I know that 5 is going to go into 70? Sydney?
Sorry,
Is she frozen for anybody else?
huh?
I couldn't hear you there, Sydney. Can you say whatever you said again?
Because you can because you can keep on adding on.
Right. Because 70 ends in a 0, and 5 goes into everything that's 5 and 0. So, what is the least common multiple? Everybody take yourself off mute. We're going to try this like we were trying yesterday. All right. Our least common multiple, 3, 2, 1.
35.
35.
All right, so I just write myself an LCM equals 35. All right. Jay, can you please stop typing this stuff, please?
Okay.
Thank you. All right. Everybody put yourself back on mute.
Okay.
So the only one I want off of mute, Rebecca, does this concept make sense to you?
Yes, sir.
Okay, thank you. Everybody else, thumbs up if you remember this, thumbs down if you don't quite remember it. Beth, please mute yourself. Okay. Now what we're going to do is we're going to take this to the next level. And the next level is using this with fractions. So if we have 1/3 plus 1/5, like this, are we able to add these? Thumbs up or thumbs down? Why are we not able to add these? Let's go, Jay.
Because the denominators are different.
Right. And what do we need when we're trying to add or subtract fractions? This is for anybody.
Could you repeat the question?
Yes, what do we need when we're adding or subtracting fractions? Corinne.
You need alike denominators.
Right. And when we have like denominators, do we add or subtract those? And I'm looking for... let's go, Rebecca.
When you have like denominators, all you do is you just, what's it called? You leave them the same, you just move them over.
Absolutely. So, but we don't have like denominators. So what we have to do is we have to make like denominators. And the way that we're going to do that is with the thing, the least common multiple that we just did. So what we have to do is you take the denominators, the 3 and the 5, and we're going to find the least common multiple of those two numbers. So go ahead and find the least common multiple of those two numbers. Jay, mute yourself, please.
Oh.
All right. I'm going to give you about another minute. All right. Somebody help me with my 3s. Beth? Beth, you can help me with my... Okay.
3, 6, 9, 12, 15.
Okay. Somebody help me with my 5s. Thank you, Beth.
So I have a question.
Yeah, what's up?
For the least common?
Yes, we need the least common.
Okay.
I need help with my 5s. Rebecca?
Five, 10, 15, 20, 25.
Good. Do we have a match yet? I'm seeing some thumbs up and I'm seeing some thumbs down. Dylan, I see you have a hand up.
$15 and $15.
Good. 15. So now what we're going to do is up here at our addition problem, so everybody's markers or pencils, whatever you happen to be writing with, put them down. And I'm going to make this what I call my answer denominator. So I just put this up here. Now I'm going to have to turn the 1/3 into something. And this is how I'm going to do it. So this is the most important step in the whole process, so I need everybody's eyeballs up on the screen. And this is going to be difficult because I don't normally write it this way. All right. So what I say here, and I have a little saying, Dylan, mute yourself, please. I have a little saying that I say to myself when I'm doing this, and I say 1/3 times something, and I just put like an empty fraction, equals something over 15. So it's 1/3 times an empty fraction equals something over 15. Now I work backwards. What do I need to do to 3? What do I need to multiply with 3 to get 15? Corinne?
5.
5. And now the cool thing about fractions, whatever you do to the bottom, you have to do it to the top. So all I do is I put 5 as my numerator also. Then I do 1 times 5, which everybody, take yourselves off mute. 3, 2, 1.
5.
5. Pretty straightforward. Now all I'm going to do, mute yourselves again. All I'm going to do is take this 5 over 5/15, and I'm going to put it right here. Okay? The reason that works is 5/15 is equivalent, or it's equal to 1/3. How can we prove that those are the same fraction? What can we do to prove that they are the same thing, or that they're equal to each other? Grant?
The way you can do it is because if, like, 5/15, if you divide it, you get 3, and 1/3 is exactly kind of like 3. So.
Yeah, that's one way to think about it. And Corinne, what else do you have to add?
You could cross multiply.
Right, you could cross multiply. If we do 1/3 and 5/15, cross multiply it, we get 15. Pretty straightforward. But we need to do the same thing to 1/3. Or 1/5. We already did the 1/3. Does anybody remember the little saying that I say to myself to help me out in writing this? Okay. Corinne, do you want to take a stab at it?
Sure.
Okay.
The first fraction, wait,
So 1/5.
Times something else equal something 15ths.
Good. Very good. Everybody give Corinne a round of applause. Even though you're muted. Or you can unmute yourself, and there we go. All right. Now, what do I do from here? Grant, what do you think I do from here?
I think you could, like, you could go, well, it's kind of like the first one.
Mm-hmm.
Well, kind of.
Kind of. You're on the right track. I think Jay could help you out.
Yeah, I'm surely, I raised up my hand before my mind was even thinking.
Oh, no problem. You're taking a risk. I like that. Okay. Jay, do you have something to help? Okay. We figure out what we do with, we multiply with 5 to get to 15. So what do we multiply with 5 to get 15? Jay?
2 things. 3, and isn't this what we were doing the other day before the snow day?
What you and I were doing?
Yeah, with it.
Yeah.
Yeah.
Yeah,
Oh.
this is, yep. Remember I told you I was giving you a little preview. So, whatever we do to the bottom, we have to do to the top. So what do I do with that 3? Beth, what do I do with the 3? Beth?
Put another 3 for on top.
Yep, the numerator. So then, Beth, stay on so 1 times 3, what is that, Beth?
3.
3. And then, Dylan, where am I going to put this 3/15? Beth, can you mute yourself, please? Dylan, so I put the answer to 1/3 right under 1/3, so where do you think I'm going to put the 3/15?
Under the 1/3.
Well, we already have something under the 1/3, so we're going to we have a space under the 1/5 though. So where do you want me to put it?
15. Under the 15 over there.
Like right around here?
Yeah.
Okay. Then we just drop our 15th straight down. Are we adding or subtracting in this problem? Use your fingers to show me a plus sign or a subtraction sign. Good, I see some addition being made on your fingers. Are we going to add our denominators? Thumbs up or thumbs down? Do we add our numerators? Yeah. 5 plus 3. Everybody off mute. 3, 2, 1.
8.
8.
So 8/15 is
8.
yeah. Mute yourselves again. So 8/15 is our final answer. See there. All right. Does this seem like this is a lot of steps? Thumbs up or thumbs down? Do they seem like they're hard steps or just a lot of steps? Corinne?
Just a lot of steps.
Right. It's really easy because all it is it's the least common multiple stuff from yesterday. We're just turning into some new fraction, then we're adding. So it's all that's new today is just that making new fractions. We already did LCM yesterday. Last week we were doing adding fractions, so we're just adding one new step to this. So it's really not that challenging as long as you remember the steps. Are we ready to try one together? Okay. Everybody have a piece of paper. We're going to do it together. I'm not going to set you loose by yourself. Everybody has a piece of paper ready? Let's do 3 6 plus 1/4. That's going to be what we're going to start with. Jay, you came off mute.
Sorry, I had my paper on my
Hey, Bradley. All right. Everybody, thumbs up if you have this written down so far. All right. So my first step, does anybody remember what the first step in the whole process was? Corinne?
You write down the 6 and the 4, and you do the multiplying.
And do you remember what the official name is? That is exactly correct, but do you remember what that skill is called?
Least common multiple.
Right, so everybody go find your least common multiple. Thank you, Corinne. Jay, you fell off of mute again.
Well, I'm uncomfortable. I'm moving around. I moved from the kitchen table to my couch to the kitchen table again.
Beth, do you have a question?
Are we just looking for the least common?
Yep.
Okay.
Do you have another question? All right. For the sake of time, what does my least common multiple end up being? Grant?
Your least common multiple is 12.
12, correct. Because we've got a 6 and a 12 here. We've got a 4, 8, and a 12 here. What do I do with this 12? Where do I put that? Think back to the last problem. Where did I put my least common multiple? I'll give you guys a clue. Jay?
As the denominator.
Good. The answer denominator. So right now, you should have this written down on your board. Or your paper, if you're on a paper. Now, what was my next step after I found my answer denominator? What did I start doing next? Rebecca?
What you do next is you do the same thing, but with your 3 and your 1.
You're on the right track. I do have to do something with these fractions, but I don't necessarily have to find their least common multiple. You're on the right track, though. I am doing something with the rest of the fractions.
Oh.
Okay? Do you want to pick someone to help you out?
Grant?
You would cross multiply.
You're getting ahead of yourself. You're going one step further. Fran?
You do 3/6 times blank equals blank 12ths.
Good. So everybody, I want you to stay on mute, but I want you to say that as you're writing it down. I want you to say 3/6 times something, or blank, equals something over 12. And I want it written down like that. So for your 6 should look a lot nicer than mine does.
What do we say again?
Make sure you have this written down on your paper.
Yeah, I have that written down.
Okay. Now, Dylan, I'm coming to you next. Dylan, what do I have to multiply with 6 to get 12?
2.
2. And then Sydney, I'm coming to you next. Whatever I do to the bottom, I have to do to the top. So if I put a 2 on the bottom, what do I have to do to the top?
Put a 1 on the top.
Not a 1 on the top. We want to do exactly the same to the bottom that we did.
2.
Yeah, 2. Everybody, I want you to say that out loud. Keep yourself on mute, but just say that whatever I do to the bottom, I do to the top. So I should see your lips moving, but I shouldn't hear you. I could definitely tell some of you are like seeing that. Now, I go straight across. What is 3 times 2? Everybody show me your fingers. Yeah, it is 6. Where am I going to put this 6/12ths? Dylan?
On top of the 12.
No, not quite. You're going a couple steps too far. That's not our whole answer. That's just our converted fraction for one thing. Grant?
You put the 6/12 instead of the 3/6. You put the 6/12 there.
Right, so underneath. All right. Are we ready to add these fractions yet? Give me a thumbs up or a thumbs down. Why aren't we ready? Jay, why are we not ready to add these? Hey, Reagan.
You're going too fast. I'm kind of getting lost.
Okay, okay. That's perfect. Okay, we've already changed the 3/6. Did we do anything to the 1/4? So, Corinne, what do we have to do now?
Then you do 1/4 times blank equals something twelfths.
Good. All right, everybody, mute yourselves. I don't want to hear you, but I should be able to see your lips moving. I should see your lips saying 1/4 times something equals something over 12. So I'll be looking at your lips. I like the way Grant was using his hands for that. All right, so what do I ask myself at this point? Okay, Corinne, help us out.
How many times can, no, 4 times something equals 12?
Right, so Beth, what times 4 will give me 12?
3.
3. And Dylan, whatever I do to the bottom, I have to do to the top. So what am I going to do with that 3?
Can you say again?
Yeah, whatever I do to the bottom, I have to do to the top. So what am I going to do with that 3?
3. Put it the 3 up there.
Yep, on the numerator.
Yep.
Now we've got 1 times 3. Everybody show me your fingers. Beth, please mute yourself.
Hey, Mommy. Hi.
So we've got 3/12. Where does that gonna go? Hey, Reagan. Where does the 3/12 go? Rebecca?
The 3/12 would go under the big horse.
Yep. I think you're coming in and out, but I think you said the 3/12 would go under the 1/4.
Yes.
Okay. Rebecca, am I adding or subtracting this problem?
Adding.
Adding, very good. What am I missing on my board for this problem, other than a nice looking plus sign? What am I missing on this equation? Rebecca, you're on fire. Take it away.
You would put, well, you would put where the denominator, you would put the place where there's the denominator,
Like this.
and the denominator would be 12.
Mm-hmm.
So you add 6 and 3,
And what?
and you would get 9.
Very good. So this is an answer. I will tell you this would not be our final answer, but we're not quite at the step where we would find out how to make this our final answer. Jay, do you have a question?
No, I just wanted to say, can you start holding your board just a slight higher when you're writing on the bottom, because I can't see because of everyone else's faces.
Oh, I didn't even think of that. Yeah. Is that good height?
Only when you're writing on the bottom of the board.
Okay. So, eyeballs here. Again, difficult or just a lot of steps? Difficult, 1, a lot of steps, 2. So, okay, so we're feeling some feel difficult, some feel a bunch of steps. Okay. Only one new thing in this whole thing. Yesterday was LCM, last week was adding fractions, this week is just making like fractions. I'm going to give you one, and if you don't totally get it right now, that's perfectly okay. We'll do another one tomorrow. Same concept. If you can make it for tomorrow, we'll do another one tomorrow. Jay?
We're having another session tomorrow.
Yeah, we have a snow day tomorrow.
Again? Cool.
Did you guys not get that message?
Nope.
Oh, maybe I wasn't supposed to tell you. My bad. So I'm going to give you a problem. I want you to try it all yourself. I will leave my board up here so you have like a guide of what to do. I'll try to see if I can freeze my screen like I can the smart board. No, I don't think I can freeze my screen. All right, I'll just hold it the whole time. But your problem is going to be the problem that I'm going to put right here in this box down here. So I am going to give you, let's go 1, no, I lied. Let's do 2/5 plus 1/6. I like that. So this is the problem you're going to be solving right here. And I'm going to give you as much time as you need for that. Jay?
What do I do when this stupid box keeps popping up under the microphone even if I'm muted?
The box that's...
It's a blue box that pops up under the microphone where you mute it, and it keeps telling me to unmute it if I want to talk.
Oh, you just ignore it.
And every time it beeps.
Okay, you just got to ignore it.
Okay.
Jay?
I'm confused. Can you walk me through like how to do it again? Because I forgot within a minute.
Yeah, okay. And that's okay because this is our first day. Just think like long division. I'll walk through it with Jay. If you want to keep doing it yourself, great. If not, you can follow along with us. But let me clear my board. Jay, do you have the problem written down, Jay? Okay, good thing I can read lips. All right. Jay, can you give me the problem, please? Again, I just erased mine. Jay, it would be really helpful if you took yourself off mute.
2/5 plus 1/6.
Okay. So for Jay or anybody who is listening, Jay, do you remember what the first step was? No? Okay, that's fine.
I
First step.
completely forgot it all.
Okay, that's perfectly fine. The first step was to find the least common multiple of the 5 and the 6. So go ahead and find the least common multiple.
So count by 5s and then count by 6s?
That's correct.
Okay.
Hi, Hannah. If any of you finish the whole problem, you can raise your hand and I'll take a look at your work.
Sorry, Bradley's humming.
No problem. All right. Did you find the LCM yet, Jay?
I only have to put one more down.
Okay.
Oh, you have to keep going more 5. You have to keep going 5 more.
Okay. What's the LCM?
30.
30.
30.
Good. So then I will put the 30 up here as my answer denominator.
Okay, so you take the... Okay.
And then this is where I'm going to start turning the fractions into new things. So this is where I say, like, do you remember the little chant thing that I was doing?
Nope.
Okay. Well, you're going to repeat it after me, okay?
Okay.
So you go 2/5
2/5
times something
times something
equals
equals
something over 30.
something over 30. Oh, now I think I got this. 5 times what equals 30?
Mm-hmm.
So 5 times 6 equals 30.
Mm-hmm.
And then I don't know what to do on the top. Do you do like 2 times 6?
Well, I don't have anything in my top right now, so what do I have to do to whatever I do to the bottom?
You do to the top, so
Right.
6.
6.
And then 12.
Good. And then where I'm going to put this 12/30.
Yeah. You put that up where you still have I don't know.
No, you're on the right track. Where I am putting it up, but where am I putting it specifically?
Like at the top of your board?
Yeah. Grant, help him out. Grant, you can help him out.
No, I was done.
Okay. Well, we're kind of going over it at this point, so everybody can kind of follow along.
He was froze in that position where he looked like...
Okay. Rebecca, where am I going to put this 12/30?
You will put the 12/30 under the 2/5.
Good. 12/30. And then, Jay, do you remember where to go from here?
No.
No? Okay, who can help him out? Beth, I think you're finished. What do we still have to do in this one?
You need to put the 12/30. Wait, for the 1/6.
Yeah, what do we have to do about the 1/6?
Do 1/6 times blank equals blank over 30.
Good. And then Dylan, oh, that's a terrible 6. I keep making really bad 6s. All right, Dylan, what am I going to do from here?
You're gonna see how much times in 6 going to 30, which is 5.
Okay, Sydney, what am I going to do with that 5 now?
Huh?
Remember, whatever I do to the bottom,
What are you gonna do with that 5 whenever I just said, how many times in 630, which is 5?
Dylan, you can help her out if you want.
Okay. Remember, you can put your 5 up here.
You got it, Sydney. Remember, whatever you do to the bottom.
Putting your 5 like up here. Then you put the 5 up above.
Up above. Because 5 over 5 is the same thing as saying 1. So you can do anything times 1. Now, let's bring it back to Jay. Jay, what do I do from here? Dylan, can you mute it, please?
You do 1 times 5, which is 5, and then you put the 5/30ths under the 1/6. And then, I don't know.
Okay. Who's going to help out here? Corinne?
Then you do that adding 12 plus 5.
And what's that going to give us?
17.
Okay. And then I'm going to add my denominators?
No. You're
Why not?
Because the denominators always stay the same.
Okay. You said it correctly.
Okay.
Alright. And now we're done. Pretty straightforward. Again, a lot of steps or challenging steps. A lot of steps or challenging steps. Yeah, a lot of steps. But this is the last thing I want you to make sure that you have written down, because this is kind of your step-by-step procedures. Someone's not muted. Grant, mute yourself, please.
Sorry.
It's okay. So step number 1 is you find your LCM.
Mr. B, can you give me a minute? I kind of lost my pencil.
Okay, well, I'm going to hold it up. So step number 1 is LCM. Step number 2 is like denominators. Which was this whole like, and we're going to say fraction.
Can you say the steps?
They're written down right here, dude.
I know, but you just have LCM. Do you find
Find the LCM.
Yeah, just do the same thing you did with these problems, just with the problem.
Right. I'm just writing down the steps to solving the problems. So it's you find your LCM, you do the like denominators, which you do fraction times blank equals blank over LCM. That's supposed to say LCM. I know I have wonderful handwriting. It's beautiful, I know. And then step 3 is you add or subtract. And then there will be a step 4, but we won't get to that today because we're out of time, almost. We'll probably get to that, not tomorrow, because tomorrow we're going to be doing the same stuff. But does anybody have any questions about this stuff? Jay?
Do we have to do another problem, or
No.
are we just help to memorize the steps?
We're just going to learn the steps.
Okay.
And then tomorrow we'll practice again. Any questions? Okay. Like I said, tomorrow is a snow day. How many of you would like to do this again tomorrow? Okay. Ask your parents if the same time works for you tomorrow. Give me a thumbs up whenever your parents say yes. All right, Corinne. Is that a thumbs up, Beth?
Is it off? We don't know yet.
Okay. So I'll put a question mark next to Beth. I see that aren'ts are good. All right, Dylan and Sydney, I got you. I think I'm just waiting on. Okay, Grant is good. And Jay's coming back. Rebecca, I don't know if you give me a thumbs up or not. I can't see you. Is that a thumbs up? Rebecca, you can take yourself off mute and you can just say yes or no.
Yes, it's a good time.
Okay, cool. And Jay?
Yeah, probably.
Okay. I'll send a message then, too. All right, last thing, I want to take pictures of you guys all again. Actually, no, this is on YouTube, so I don't need to take pictures because it'll be on YouTube. All right. Thank you for joining me. It was a good time. Practice this stuff, and so you can get better at it, and then tomorrow we'll meet and we'll do the same thing. Any last-minute questions? Grant, you have a question?
How much more snow days do we have?
We have tomorrow so far, but they haven't said any other days. But hopefully we get to go back soon because I would like to see you guys other than in a computer screen. All right, but thank you. You guys were really good both days, yesterday and today. So I appreciate it, and I will see you tomorrow.
Thank you for teaching.
Thank you for
Okay,
learning.
bye.
Bye.
Scout. Say bye, Scout.
Bye.
Bye.
We're hanging up now.
Okay, bye.
Josie. Alright. Hang up.